In the second part of this chapter, we look at the concept of slope, y-intercept, and parallel and perpendicular lines. So, as a review, we have, as mentioned in the last video, y equals mx plus b as our slope-intercept form of a line. Why is it called slope-intercept form? Because it gives us the slope and it gives us the y-intercept. Remember that slope is equal to rise over run, or delta y over delta x, or y2 minus y1 over x2 minus x1. As a review, remember that horizontal lines have a slope that is equal to 0, and therefore are defined as y equals whatever that point you want it to be. And vertical lines have no slope, or an undefined slope, and are defined as x equals that value. Lastly, parallel lines are defined as two lines with the same slope, and perpendicular lines are two lines with opposite reciprocal slopes. As a reminder, opposite reciprocal slopes mean, for example, if the first slope is 1/2, the second slope is a reciprocal but also negative, so like -2. So let's do one problem together. Let's let 3x plus 2y equals 6. 1. Let's graph the line. Remember, this is standard form of a line. So let's graph it. In standard form, it is easier to find the x and y intercepts versus actually converting it to slope-intercept form. If you remember, we can find the x-intercepts by setting y equal to 0. And we can find the y-intercepts by setting x equal to 0. Therefore, we could use what we call the cover-up method. For instance, if we want to find the x-intercepts, we cover y.
Cheyenne Holloway, please report to Mr. Woods in room C117.
So in this problem,
again,
x is equal to 2.
Holloway, please report to Mr. Woods in room C117.
So this would be the y-intercept. Sorry, the x-intercept. If we want to find the y-intercept, we cover up the x's, and we're left with 2y equals 6. So y equals 3. So this is the y-intercept. So our graph would be x-intercept of 2, y-intercept of 3. Next is find the slope. There are two ways. Through our graph, we could just see that it is 1, 2, 3, 1, 2, so it's down 3 over 2. That's our slope. We could also take this and convert it to slope-intercept form. We could say 2y equals negative 3x plus 6, so y equals negative 3/2 x plus 3, and there's our slope. So there are two different ways of finding the slope in this problem. The y-intercept of the line, again, we found the y-intercept of the line, which in the first step, by setting the x value equal to 0. We could also find the y-intercept of the line using the slope-intercept form, so it must be 0, 3. Let's find an equation of the line that is parallel to it and passes through, I don't know, let's say the point -1, 1. I have not mentioned the form of point-slope form, but one goal over this year is to get you guys more comfortable with the point-slope form of line because it makes these questions so much easier. I'll talk about it in the next video or two, but in this video I will stick to slope-intercept form. So we know parallel lines must have the same slope. So we know our slope is -3/2 x plus b. So now we can plug in the point, -1, 1. So we get 1 equals -3/2 plus b. Therefore b must equal 5/2. So our equation of this line would be y equals -3/2 x plus 5/2. If I did the same question but now change it to being perpendicular, I want to keep it exactly the same, so we're going to do perpendicular and it still passes through the point -1, 1. We would approach it exactly the same way, except now, since the slope was -3/2, now it will be the slope of the perpendicular will be equal to 2/3. Again, it's the opposite sign and reciprocal. So 2/3 x plus b equals y, and now we can plug in our point. 1 equals -2/3 plus b. Add the 2/3 over, so we get b is equal to 5/3. In the last problem, I just want to double check. I don't remember plugging in -1. I remember plugging in 1. I did make this real quick mistake. I didn't plug in -1 for the x value. Therefore, this would have been +3/2. So when we add this over as -3/2, it would have been -1/2. So I'm going to real quickly fix that. Be -1/2. And that wraps things up. Real quickly, because some of the problems in this chapter refer to geometry figures, let me do a quick review of geometry. Remember that a square has 4 equal sides and 4 right angles. You can see where I'm going to play with this. The 4 equal sides can be found using the distance formula from the last section, and the 4 right angles can be determined by the slopes in this section. If we have a rectangle, that's defined by 4 right angles. So all we have to do for a rectangle is see that they are perpendicular. For a rhombus, we have 4 equal sides. So in other words, a rhombus says the distances are all equal. Rectangle says we have 4 perpendicular angles, and the square has both of those conditions, as stated in the hierarchy studied in geometry. Next, we have a parallelogram. And a parallelogram says 2 sets of parallel sides. So again, that idea would you'd have to find the 2 parallel sides, 2 sets of them, finding that their slopes are equal. We have a trapezoid, which only has 1 set of parallel sides. And the last figure I want to make reference to is an isosceles trapezoid, which is obviously a trapezoid where the 2 sides are equal length. So that's a quick review of some geometry figures. The reason why is over this course of this chapter, we're going to be proving whether a figure is a rhombus or rectangle. We're going to be finding the perpendicular bisectors of things, and we have to be clear on the terminology of these and what is needed to support that it is a square, or it is a rectangle, or it is a rhombus, and so forth. So with this, you should be able to complete section 1-2 of the summer assignment.